Thank you for coming today. I'm going to get started. I have to provide a warning at first. I don't know why I decided I wanted to do this talk, and it ended up being much harder than I thought. And when I give you this warning right now, I'm trying to lower your expectations. But it'll be okay. The other thing I realized when I went through several variations of this talk is that I didn't want to provide a lot of conclusions. So when you hear things, just think about whether that seems like a reasonable statement or an unreasonable statement and come to your own conclusions. I will give some general conclusions at the end, and my opinions will slip through, but I'm going to try to stay even-handed as I can, which is very difficult in a talk like this. So, my name's Tom Enebo. For people who know me, I would normally be doing a talk about JRuby, but I'm not today. I'm employed by Red Hat, and I've been professionally programming for almost 30 years now, so that doesn't necessarily qualify me for this talk, lowering the expectations, but I've used a fair number of languages in the last few decades. I also happen to have a bachelor's degree in computer science, the best 13 years of my life. I went to school for a few years, or a couple years, and then I ended up getting a job as a programmer. And then over the course of the next decade, I was taking 1 or 2 classes at a time until I finished it, because I wanted to finish it. Again, having a bachelor's degree does not necessarily qualify me for this talk either. Expectation a little lower, I don't know. But I did take coursework. I just have to remember back 20 or 30 years. I never thought I would publish this picture, and I think Radislav wishes that this picture was not published. I was at the first GeeCON speaking, and this was the after party after the after party. I don't remember much at this point because some lady said, "Give me a bottle of vodka," and that freaked me out because I'm like, you can buy whole bottles of alcohol in Poland? And obviously I didn't take the picture of that. I just left my camera somewhere. So it's great that they have me back here this year. So let's have a quiz here. There's 3 choices, whether you prefer statically typed languages, dynamically typed languages, or you don't really have a strong preference. So how many people like statically typed languages? Okay. We're about 60% maybe? How about dynamically typed? Okay, there's 3 people. So we'll say 3%. That was lower than I thought. There are dynamically typed languages on the JVM. How many people don't have a strong preference? That should be the rest. And it is. I'm in this third camp. I don't particularly care. I obviously like some things about various languages, but it just comes down to the features of that individual language. I almost added this question. It depends on what I'm doing, but I have a feeling everyone would raise their hands because we're programmers and we like to have lots of flexibility in our answers. Now let's play a game. I call it static or dynamic. We're going to look at some code sequences, and you don't have to scream it out. Just think about your answer. I'll kind of lead you a little bit on this, but we'll look at some syntax, and you'll tell me whether it's statically typed or dynamically typed. Well, we're at GeeCON. Java, statically typed, fairly obvious. Here's Ruby. Some of you may have never seen Ruby, but it's dynamically typed. What do you think? Yeah. Okay. Be quiet in the front. So we go to the answer section. The first one actually will run just fine in Groovy, and it's dynamically typed. Of course, it is valid Java as well. So this is not Ruby, it's Crystal, and it's a statically typed language. Haskell, and we're just going to say static. So if you get nothing else from this talk, and you didn't realize this, you can't tell the typing system from syntax alone. When I was preparing this talk, I decided I should go and see how people argue this topic online. I started looking at definitions, and definitions were sort of all over the place. I settled on a couple of definitions that seemed to be a bit more consistent. This was a prestigious university in the United States, and it was some PDF notes for languages class, and it basically just summarized statically typed languages do type checking at compile time, and dynamically typed languages perform that type checking as it's executing or at runtime. And then I thought, well, the greatest place to look up computer science programming sort of things is c2.com. It's a great wiki. I highly recommend people read up on it. You don't have to read all this, but I thought the first sentence was pretty funny because it seems like it's in almost total contrast with the previous definition. And this may be more technically correct, that you make sure whether it's at compile time or runtime, the definition of the type is never violated in some way, but this isn't how people argue about it on the internet. They argue with the previous definition. This also cracked me up. I went to the dynamic typing page, and I saw pretty much the computer science definition for it. So C2 is just a collection of random people on the internet. Who knew? I just modified this university definition just a tiny bit here. Before execution starts, there's some type checking, or the type checking happens during execution. And this snippet of code we'll use as an example. If we look at this line, and this line happens to have a type error on it, and it's statically typed, the compile phase will pick it up, and you'll get a nice error message before anything executes. If you're in a dynamically typed language, you're only going to see that error if something unlikely occurs. And I think this boils down to the biggest reason why pro-static typing people are frightened or dislike dynamically typed languages. So I think this is one of the key disputes. Other thing I just want to point out quickly, before execution just means that there's a compile phase. That compile phase could be part of executing your program, or it could be a separate compiler command. It seemed like there's a lot of confusion about that on the internet as well. And I would say over half the definitions of static typing on the internet seem to think that it has to be explicitly typed. This was on Oracle, I think. But as we've seen, you don't actually have to go and explicitly declare types. In Crystal, it just uses type inference, and by virtue of the math it's doing, it binds it to a 32-bit integer. And it's also sort of interesting, if we go back to Groovy, Groovy actually has type declarations, and those things are happening at runtime most of the time. So let's go to the central big argument. How important is it that a dynamically typed language won't pick up this type error? I think if you talk to two people that are firmly on the opposite ends of the spectrum, you get these two standpoints. The static typer is like, well, I really like the type system. It tells me when I did something wrong. It's like free debugging. I get it for free. Whereas the dynamic typer is like, the typing isn't really that helpful, and because I have to go and do some form of testing to prove correctness in my program, I'm going to catch those errors from testing. I was talking to someone the other week about this in the dynamic typing camp, and this is like how strong the opinion is on it. If a compiler type check is the reason that your application's going to fail, you're doing something wrong. So this is a pretty bold statement. And of course they think that because of excessive amounts of testing. Dynamically typed people like to write lots of tests. But of course, from their perspective, you do have to test correctness of your programs, and type system can't do it all. So you have to write some tests anyways. As you go and run those tests, if there are type errors, you're probably going to see them. They also will be bold and say that the type system isn't providing as much value as the static typing person thinks, which is sort of false and sort of true. But they're obsessed with how many times and how fast they can run their test suite. It's a really big deal. So I'm not so sure that they would love having to wait for a compiler. Although there's sort of a compiler anyways, but they don't think of it that way. Test-driven development gets an honorable mention as well. This is where you just write your test first, and then you write the code to satisfy the test. I don't do TDD. I have done it, and I've enjoyed it in some ways. Because you're writing your test first, if you haven't written the API yet, it's great because you can go and iterate over a design 2-3 times and build up the tests, and then you make the implementation. So it gives you some time to play without being influenced by your implementation. I find once I implement something, my desire to actually change it goes down because it's more work. Dynamic typing has less of an impedance versus static typing because when I write my tests, I'm just not going to see a sea of red across the entire screen. None of the tests will pass, but at least there's something there. And then it's also nice because as you partially build up your code, you'll start making individual tests pass, and you'll start to see green impinging on the red, and it's a nice psychological feeling that you're like making this thing turn green. So it's a nice psychological aspect to it. But I'm kind of lazy, so I always write my tests afterwards, personally. So a couple questions we might still have at this point is, what if not all the valid type values are actually tested? So you've exhaustively tested when you pass in a string, but your program might pass in a date. What happens there? And since I think no one in either camp thinks 100% code coverage is a good idea, how do you deal with the fact that you might have a type error in those sections of code that you didn't think were meaningful to test? This is a personal experience for me. When I was making these slides, I realized this is true. I probably get more class cast exceptions in Java than I actually get type errors in Ruby. And I tried to think about the reasons for this. The first thing is like, oh, it's the type system. Java's like lulling me into a false sense of security. I thought about it a bit more, and I don't think that's true. Then I thought, oh, maybe Java's type system is a bit weak. Maybe it's showing its age. It's pretty old now. But I realized the truth after a little more thinking. I enjoy writing tests in Ruby, and I loathe writing tests in Java. So I end up writing a lot more tests in Ruby, and guess what? I have less type errors. So food for thought, maybe. So another question we might ask is shorter code more likely to be correct? I think intuitively we might say yes, but it sort of depends. Here's two examples in Ruby. This top one is from Active Record. It will find all the users in a database that wants a weekly subscriber and send out a mailer or an email. Without knowing Ruby at all, this is inherently what it does. And it happens to be just two API calls that are just so heavily tested by the Rails framework itself. It's very hard to imagine that this could fail. However, while I might not unit test this, I would definitely add an integration test to make sure I was actually sending out emails. Below, this one might not look so nice, but to a Ruby developer, you can read this in about 1 second and know what it does. You find all the developers, you extract the pay out of it, and then you add them together. And then here I'd probably just test to see if I got the right total. I hate it when people go and show a language and say, look at how much shorter it is than your language. So this is a fun example. There's 3 different Ruby implementations implemented in 3 different languages. And you can see they all approximately look the same. This is the majority of languages that at least have the same ancestry. They tend to look the same. And you could even argue, oh, well, the Ruby one is shorter, but there's not a lot to be gained that it's less columns. It's about the same amount of recognition or cognition and understanding how it works. All right. So we'll go over to the other side. People who use statically typed languages like the benefits that their type system provides. They feel it makes them productive. I know I feel productive when I write Java code. I don't feel like most of the time it's in my way. And so most of the time I find it's virtuous. Sometimes it's not. So when I first started programming, I was writing a lot of C code, and I spent a majority of my time just figuring out why I had segmentation faults. But I was also at the university, and they start making you use other languages. Started using TCL. I picked up Perl, and I was like, what the hell? There's no memory errors anymore. Wow, memory safety is awesome. Now I don't. Oh, actually, that's not even really true. Sometimes you have to. C will never go away. Kind of, unfortunately. Another example for me personally, I've started playing with Rust in the last half a year, and I find it really, really, really hard to make the compiler happy with me. Once I do, the program typically works. Part of this is because it's a new language for me, and I'm not productive because I haven't figured out idioms and how to write stuff. But the other thing is they have these very specific ownership rules that I've never encountered in any other language I've used. But those ownership rules end up removing data races for the most part and make it very easy to parallelize your code. Well, this is awesome. If these are the things you're going to do, then it totally makes sense and it's going to pay for itself. This is a virtue. On the other hand, if I was going to go and download a series of web pages and do some text analysis on it, I could be using Rust for several years, and I would never be able to match the speed of doing that in Ruby. It just wouldn't happen. So the type system would get in my way in that case. Another thing I sometimes run into in Java is abstraction mismatches. So let's say I'm using I want to use a binary search tree. I already have written my application, and I already have an interface for searching. Well, what do? You end up writing a wrapper class. You go and save the search tree as a field, and then you implement your interface. And it's all brain dense, simple. You know it's going to work. But don't you sit there after you do that and go, I wish this is a little different. I feel like Java's letting me down in some way. When I actually switch over and do the same thing in Ruby, that mismatch feels a lot smaller, mostly because of Ruby's duck typing. So if I want to call something on a collection, the only thing it cares about is that that particular method it's calling at that moment exists and behaves the same. But if it does, then you're just done. None of this extra coming up with a name for a wrapper and so forth. The other really nice thing is most dynamically typed languages tend to also be open type systems, so it's never too late to go and add another method or potentially replace an existing method. And so this also reduces the impedance by being able to just add an each method or a search method if that's what you need onto that type at that time. So working environments. How do these two systems of languages differ? For static typing, I think it's really weird that static typing people almost always say IDE, and dynamic typing people always say text editor. Emacs is like the craziest thing in the world. It's not a text editor, it's an operating system. But be that as it may, if we actually look at static typing itself, there's great navigation. We can one-click stuff and go to a declaration. Find usages is very easy. It generally gives you what you want. Refactoring is very good still. There's sometimes cases where the IDE gets confused about what it wants to change, but it does what you want. During compilation, you can just jump to errors. I guess we probably all know this in this room. You can go to other libraries with the press of a button and look at its code. But static type information only goes so far. I was working the other week, and I was trying to figure out something about as Java string. I popped to the declaration. I'm like, oh, yeah, it's on the interface. And then I realized that there's 30 of them, and I didn't have enough context to understand which implementation I wanted. So static type information is helpful, but it's not always enough. Sometimes you need some runtime state or some background knowledge to know where you want to look. On the dynamic typing side, there is still pretty good navigation. The problem here is sometimes you might have multiple choices. In that case, you'll need to know a little bit of context to know which definition to jump to. When we get to find uses, things are not as nice. I went and queried a bunch of people on what they do, and they all said git grep, so they're using grep, so that's not as good. There is another thing that people use. cscope was invented to track callers as well as definitions for C, and there's some static tools that will go and generate potential callers for other languages and then generate a cscope file. So you can do that. But for go to definition, most people use C tags. That seems to be overwhelmingly what people use. Refactoring is pretty bad. If you want to change something, it sounds like everyone's doing it by hand. I couldn't find a single person that was brave enough to just do a mass replace. There's no compiler, so there's no integration. And you can just as easily generate C tags on your dependent libraries, so you can easily navigate. Of course, there's something that's better than both of these. If you actually live in an image, like a dynamically typed language like Smalltalk, you not only have great navigation in your editor, but you also have a lot of context because you have live objects. Unfortunately, I don't think image-based languages have really taken off. So what we have instead to get additional context is REPL, read, eval, print, loop. Lisp is backwards. That's the joke. All right. REPLs are just interactive shells. Both statically typed and dynamically typed languages can have REPLs. I've noticed that every dynamically typed language seems to have a REPL and seems to be used. That's not always true in statically typed. Some languages like Haskell use it heavily. Java really just got JShell recently in the grand scheme of things. Although I guess there was Bean Shell. So there's been a REPL for Java for a long time. But in the shell, you just type in your command syntax and execute it, and you can see the results. And you can learn stuff. And typically what most people use REPLs for is just trying something out. They're going to add code, but they don't want to like fire up at their entire web framework to see if it works. They're just going to go and try something and play a little bit. And people obviously use it for debugging as well, although there are debuggers in every language. So I'm just showing you some screenshots for, oh, that's a little dark. For pry, this is one of the few REPLs that Ruby has. In this case, I'm kind of simulating a debug session where I'm trying to figure out some more information on this topic object that I got, so I'm going to jump in right there and do it kind of a debug style. So I can go and ask topic for its state, and it's going to display it. I could call methods on topic and play around. I could do any Ruby in there at all. I can see what methods are defined on it, and these tools all have tab completion, so if you have an idea of what you want to use, you can. Or if you just knew part of it, you could grep through all the methods using the Ruby programming language itself to file down those methods. So it's neat. And lastly, kind of to make up for the fact that you can't always go to the right definition of things, now that you're in a REPL, you're in a live state, and you know exactly what it's going to call. So here I have show source for the method, and it displays it, but I could have just as easily put edit here and went to that and then fixed that method if it was broken. Okay, so this is my little opinion section. I never ever see it the other way around. I only see it this way. The larger the code base, the harder it'll be for you to understand it if it's dynamically typed. I have a little straw man guy, but I bet you I saw this at least 100 times in the last 2-3 weeks when I was doing this. People say this continuously. 2 arguments I got. Static typing is documentation. So having they really mean explicit typing in this case. So if I know I have hash map persons versus just persons, I know something about that. And that has some validity for sure. The other one is that the navigation is better. That's partially true, right? But I've never actually experienced this, not from a type system level. Generally, when a project's organized well and broken up into components and sensible libraries, I have no issues at all in either language. But once it's just one big blob of crap, it's horrible. And so if the argument is that statically typed languages are better in a blob of crap than dynamically typed languages, it's sort of like saying my boat's sinking slower. I recently had to work with Ruby on Rails. I'll just point out a few things about the project. In the last month, 85 authors to 220 or 500 and something commits. This is a highly active project, and it's a fairly mature project in the fact that it's been around for, I think, 12 years, thereabouts, maybe a little longer. If we look at some other stats, it's about 330,000 lines of code. 60% of it's tests. This brings back the thing that we like to do lots of tests in dynamically typed languages. The repository has 11 main libraries in the same repo that are very well defined in what they do. And then there's lots of dependent libraries. We leverage other people's libraries and code, as all languages do. So I had to start working on Active Record JDBC again. I hadn't worked on it for like 7 or 8 years, so I effectively didn't remember anything about Active Record at a hacking level. This is the entire dependency tree for it. And one thing that amazed me is after 8 years, the code had actually gotten a lot cleaner than I remembered. I remember it being fairly messy. And I don't often see any code base after 10 years getting cleaner. So that's good. When I was looking into problems, if it involved relational algebra, I knew I had to go to Arel. If there's anything involving a model, it was fairly obvious I had to go to active model. This is model view controller framework. So it was super easy for me to hack and get into this code. So I just don't accept this. It doesn't scale as it gets larger. On top of that, this is totally anecdotal. Well, I guess that was anecdotal as well. But you don't have to go very far to find huge code bases built on top of this large framework. So people are having no problems making applications and living in this other world. Like, I was thinking about how much code must exist to handle the addressing or addresses in 191 countries. It must just be a ton of code. So please don't say they don't scale as well for new people as the code base grows. So that's my one strong opinion. Well, I might have another one coming. All right, performance between the two types. Well, obviously this is pretty nebulous. I'm going to talk about two things though. First one is what most people sit and get in heated Reddit arguments about, which is like, how fast can I go and execute a loop of code, and how long does it take on the wall clock? And the second thing is warm-up time. We're on the JVM, so we have to deal with warm-up, so we probably already know that. So here's my example. This is not real production code. It's Java. And we're going to pretend that we're going to ahead of time compile this to an executable. And we're also going to pretend we're the compiler, and we're going to optimize it. So one nice thing with statically typed languages is you get some type information to start with. So let's see how we can leverage this type information. First thing we have is fooberry. No Highlander fans out there? This would have killed in 1988. Really? I'm working so hard here. There's only going to be one fooberry in this. There's no derived types. And based on having no derived types, we know this count and this loop only has one implementation. And at this point, the compiler's like, that's a monomorphic call site. We can inline that. So let's inline it. Okay, now the program got a lot simpler. We see that we're only looping once. So the compiler will say, let's unroll the loop. Okay, now we just have a print. But now it notices that fooberry is not used. And then it looks into the constructor of fooberry and then goes, oh, there's no side effects. So dead code elimination removes it to just the single print. So obviously having early type information is a benefit, and it's a big positive for statically typed languages. In this particular example, we don't really have any idea if that was called one time or a million times. So we're optimizing a lot of stuff that might not be that useful. But we did actually have to wait for the compiler to run, and that generally is not an issue either. And when it is an issue, they generally give you command line flags to disable optimization so you can make your development time round trip be a little shorter. So I think it's provable that ahead of time compilation with static type information is going to generate something faster than something that doesn't have any type information or extra static type information. If we go over and look at a JIT, which is probably a little more relevant for us, of course the JIT can do all the same static optimizations that a ahead-of-time compiler can do, but it also profiles execution. So as it's executing, it figures out what's called the most, and when it's actually keeping track of that stuff, it starts keeping track of what types it's encountering, and then it might decide to do an aggressive speculative optimization with that type. It may, with more profiling, realize that that optimization doesn't work in dopt, but it does lots of different optimizations based on gaining this extra information that a static compiler can't figure out by itself. And because of this, if you go and watch how long it takes to execute the same thing over and over again, you'll tend to see that nice curve of it speeding up, and then eventually the runtime just says, forget it, we're done. That last statement is not really true or untrue, but the performance is about the same. We'll just say that. In a dynamically typed language, a good one, it's also profiling, figuring out what places are hot, and it's also gathering type information. So it can do all the same speculative optimizations that you would do in a statically typed language. It might actually warm up slower because you don't get that free information from the static type system, but that should be the main difference. I'm going to make the comment that for most of us, performance isn't important, or at least performance in the way that I just talked about it. Sure, we all want things to run faster, but for most of us, we wrote some site that has 100 concurrent users, and now we want 10,000. This performance probably isn't going to be an issue for you. It's probably going to be your architecture. Of course, for some people, they do have a tight loop that has to do something, and every optimization they can get is helpful. Okay. So, who cares? I think we have a tendency to go and focus in too much on an individual topic and apply too much pressure towards it being important. In this case, how important is the type system if you think about your job as a programmer? How many projects have failed from the type system choice alone? If I had to pick a number between 0 and 100, I would say I don't think I've ever had this be an issue for failure in any project I've ever done. So let's think about that a little bit. It's bad management's almost always the reason. It's never the programmer's fault. So I worked in one project where we were behind by 6 months, and they got a new manager in, and he's like, we're going to add 12 more people. And they brought in 12 more people in 2 weeks. It like doubled the size of the project, and no one got anything done for like 2 months because we were just helping these new people. Or the biggest one is probably just saying, oh, we can get that done in 3 months. In this case, this is the programmer's fault because we're like, how long does it take? Oh, 3 months. And then like 2 years later, you're done. So, but there's tons and tons of reasons why we fail. And there's probably someone here where it has been a type system choice, but I think it's exceedingly rare. So why do we focus so much time arguing about type systems? All right. The truth of the matter is, this isn't my conclusion, but if we picked Visual Basic for everything we wanted to do for the next few years, we'd probably still be successful. We'd get stuff done. But, of course, we don't like Visual Basic, so don't use that. And as I said earlier, sometimes the type system is pretty important. In Rust, if you're going to do something that had a lot of concurrency or you wanted to parallelize it again, it'd probably be a good choice. If you're going to go and make a configuration language, you might not want explicit types because it's going to be extra ceremony that you just don't need. I think even more importantly than that, there's a whole bunch of meta aspects to languages that end up being a lot more important as well. I've worked on projects where there were compiler bugs, and we kept having to get that next like weekly developer dump, and so I wasn't writing bad code. The compiler was generating bad code. It was horrible. But if you start a project and you decide there's this cool language, and you can't actually hire anyone else to work on it, you're just going to be doing it by yourself. And obviously libraries. But there's lots of other aspects to picking a language that so exceed picking out a type system. This is so true, though. I've never liked a language a lot where I didn't see there be a ton of other programmer interest. And when there's a ton of other programmer interest, there's enough people working on that project, or the project and ancillary projects, to make the ecosystem survive. Nothing's more painful than working with a language where there's not enough people and libraries start dying and no one's supporting stuff. And then you're just bitter because you can't use a language that you like. But generally, the languages you like, other people like. So, as I said, language choice is rarely the reason for failure. I think you should ultimately pick what you like, with a single caveat. You better make sure other people like it too. I went faster than I thought I would. So, thanks. I have time for questions. If someone wants to yell at me, please do. Yeah? I'm waiting for the question to be, why didn't you cover this particular topic?
Okay.
And I'll be like, oh,
no,
shit.
it's actually, that's a good topic, because I like people steaming for no need. And that's one of those argues that when it starts, you have to just leave the table. But actually, once I saw kind of research that they sum up reasons of failing of project, libraries, and typing error in dynamic languages was on the well on the bottom.
That's right.
Is that your experience?
Well, so when I started looking at this, I was going to have a section on academic research, and that was so contentious because what people would do is they would say, oh, there's these 500 papers done on comparing how fast someone could go and do a project in like just 2 single representative languages, which you're thinking, well, that's kind of ridiculous because it depends on the language. But the weirder thing is what people do is they would moderate, and they'd say, oh, well, out of those 500 talks, these 100 were garbage. And if you remove those 100 talks, dynamically typed languages just totally kick ass. But then I would go and look at the other side, and someone would like have a different group of languages and then have the exact opposite conclusion. And I don't know if that's some like cognitive bias towards wanting to go and justify your opinion, but the academic research really doesn't show one. Like individual papers will show one being much better than the other, but there's so many papers that have the exact opposite conclusion that I feel like this is almost like sociolinguistics, where people start asking questions about who has the most effective spoken language, and the answer ends up being no one. They're all just as effective because they evolve and solve the same set of problems that the human brain has in exchanging information, and they just end up being the same. So that's kind of how I look at static typing versus dynamic typing on a very general level.
I don't know if this is a question as much as a comment, but I'd love your thoughts on this. So with respect to sort of the scaling properties, do dynamic languages scale to very large code bases? It's been my experience that code navigability suffers with dynamic languages, not necessarily because the type information isn't there, but the dynamic nature of the language tends to affect the way software is constructed. So for instance, Rails is one example where I've found that it's actually very, very difficult to just be able to deconstruct a code path into this is the order of things that happen, because there's so much monkey patching and other and interception and all of these sort of dynamic style techniques at play.
Right.
You've worked on large projects in both languages. Have you not found that to be the case?
I I think there's been an evolution on Ruby on Rails in particular, and Ruby for that matter. I think there used to be a lot more magic in Rails than there is today. So one example is you could take a class like user, which would then go to the user's database, and you could call find by name, and then behind the scenes it would introspect the database and go, oh, there's a name column, and then it would generate that method at runtime and then call it. And it was done through metaprogramming. So then you'd try to debug something and go, I can't find where this method's defined. And there is still some of that metaprogramming in Rails, but Ruby has actually changed things where you can now do things like source location, and you can actually print out the evaled code and figure out where it was made at least. So things have gotten better in that regard. I do actually partially agree with you that there's some cases in Ruby in particular where it is more difficult, but it's almost exclusively to metaprogramming where we're generating code on the fly. And this is the case where too much magic is a good thing. But I think there's lots of examples of that in statically typed languages as well. Okay, I'm happy you said A-OK. But yeah, I think everyone has a different experience too in different environments, and some people are less bothered by some things. Like I know people hate seeing compile errors. I tend to like it. I tend to want to just fix my thing. But as I said, sometimes I feel a type system does get in my way. So, very general opinion on a very general topic. And a generally nice day. So, anyone else?
Yeah. Here.
Ah, well, hello.
Well, first of all, kudos for finishing your bachelor's degree after, what, 13 years?
That's right.
Because I thought I would give up after my third year. My question would be, well, probably I'm misinterpreting everything here with this question, but TypeScript, right? I would personally call it like a iteration of JavaScript, right? Because JavaScript is dynamically typed. And I know I spent countless hours on debugging JavaScript code just to find that the type doesn't match. And TypeScript is interesting because it kind of gives you the freedom and makes both sides of this barricade happy. You have types if you want to, but if you don't want to, you don't have them.
Right.
Depends on your configuration. What's your opinion about that? Would that be the solution to this endless war?
I've wondered about that as well. So TypeScript's gradually typed, right? I've also wondered about this with Groovy, because if you ever want Groovy to interoperate with Java, you're going to tend to add a type signature to it so that you can specifically use it from Java. And in even TypeScript or something, I feel like there's going to be this tendency to just continuously add types over time, and they'll eventually just end up being statically typed because people are going to go, oh, in this particular implementation is doing this slightly faster, or oh, I want this to interact a particular way, and the notion that you provide a static type will constrain something, and people tend to constrain stuff when they can constrain stuff. At least that's been my observation, which is the opposite of what I think we would do, but we tend to. Oh, it says time's up. If anyone wants to talk, I'm here. Thanks.
Maybe one more question, or rather a discussion. There is F# as a strongly typed language, where the coding style is made this way that if it compiles, it works. You simply didn't write code in F# at work. I only was shown by a colleague which was a fan of that language. And there was this approach that you write the code in such a way that you force the compiler to verify the business logic for you.
Right.
So at the compile time, you check all the business logic there is. So in this particular example, you force the static types to do the validation for you, even without the test. Although you test a lot, because writing tests in that language is pretty simple. It's just like in Ruby or Python. It doesn't really look that much different, but it's strongly typed, and the compiler is forced to check all the business logic. So, what is your thought on that?
I did play with F# for like one day. I wasn't aware that it did this type proof. I didn't realize it had that aspect, but I don't really have a lot of experience with that. I've seen people say that there's problems over time with type proofs, then that they only can go so far. But I don't know a lot about it, so I don't think I can comment. Oh no, that's all right. Yeah, that's fine. Thank you. Yeah.